Hello physics students, today we're going to be covering area of a VT graph in multiple parts. So we're going to take a look at this position and velocity graph, and we're going to see how we have one segment, we have two segments, and we have three segments. So it's not just one slope anymore. And so this first segment right here, we want to look at that it's going in a negative direction. So that means it's going to have a negative slope. Then the second segment right here is going to have a positive slope, and it's not as steep as our first one. And this one right here, our third one, is going to have a flat slope, or we call it a slope of 0. All right, that doesn't mean that there's no slope, there's still slope. And so we have segment 1, 2, and 3 on the velocity graph. So I'm going to go ahead and erase this so that we can have some room to calculate our displacement. So I just wanted to point out that there's 3 different segments. And so for segment 1, our displacement is going to be, starting at the final position minus the initial position, right? So our final is 2 meters and our initial position is 6 meters. So we have delta x, displacement is equal to 2 meters minus 6 meters, which is going to give us negative 4 meters. And then our second segment, we're going to take a look at the displacement, starting with its final position of 4 meters and its initial position of 2 meters. It's going to give us 4 minus 2, which is 2. And let's go ahead and see if it matches up in the other side. So we have our first segment. Our displacement this time is going to be the area of the velocity times time. So our velocity here is negative 2 meters per second times the time from 0 to 2, which is 2 seconds. And so negative 2 times 2 is going to give us negative 4. But when we look at here, so it's below the graph, negative 2 meters per second, and then we have a time of 2 seconds. So when we calculate the area, multiply it together, we get negative 4 meters. And we see that it matches on the other side, and we are just double checking our work. We want to make sure that displacement on the position time graph matches the displacement on the velocity time graph. And now for our second segment, we're going to calculate this area here to find the displacement. And we have a displacement of 1 meter per second as our velocity, and times the time from 2 to 4, which is going to be 2 seconds. So we have 1 meter per second times 2 seconds is going to give us 2 meters. And so we want to make sure that this matches the one on the position time graph, and it does, so we can go ahead and move on. Now this third one, obviously it's going to be 0, but let me show you how to calculate it. All right, so we have 4 meters minus 4 meters is going to be 0 meters. So that means that the object stayed for 4 seconds, 5 seconds, 6 seconds, 7 seconds, or 3 seconds total. Right? So here the displacement, we have 0 meters per second, which is on the 0 meters per second line. And it stayed there for 3 seconds. So we're going to multiply by 3, and anything multiplied by 0 is going to give us 0. So 0 meters matches the other one. Fabulous. So we want to take a look at displacement, which is delta x, is the change in position. And distance, which is d, is the steps on the ground. So if you remember the Dorothy and Toto story, that's what we're talking about here. And now we're going to calculate the curve, or under the curve, quote unquote, for this example. There's 2 sections. We have one, the first segment I'm going to color in yellow, and the second segment I'm going to color in blue. All right, so for this first segment, let's take a look at what the displacement is going to be. So we have a velocity of 3 meters per second, and we have a time from 0 to 5 of 5 seconds. So to calculate the displacement, we just multiply the velocity times time. So 3 meters per second times 5 seconds. And we should get 15. And since they're both positive, our answer should be positive, so displacement is 15 meters. Here we have a velocity of negative 3 meters per second, and it took from 20 seconds minus 5 seconds to get how much time that the object traveled, which is 15 seconds. And so our displacement here is going to be negative 3 meters per second times 15 seconds, and don't forget the negative sign, which is going to be negative 45 meters. Now the total displacement is when we add up these two numbers together. So we are going to have, or let me change the color so that it is a total. All right, so I'm going to use red for total. Total displacement is going to be the first segment, which is yellow, or that gold color, plus the blue segment. So when we add it up together, we're going to get the total. And so for the first segment, it was equal to 15 meters. So let's go ahead and write 15 meters plus negative 45 meters. And so then we get negative 30 meters. Now, it doesn't mean that they went backwards, right? It just means that wherever they started from and where they ended up from, they just went in a negative direction. Okay. Now, the total distance traveled is going to be, on a velocity time graph, is adding up the areas. That's just the absolute value. Since we don't have the position time graph, we can't really calculate it. So we look at the velocity graph. So add up the areas. So we're going to take a look at the distance, which is going to be d, or lowercase d. And we're going to add up the absolute value of our yellow, which is 15. So the absolute value of 15 plus the absolute value of negative 45 meters. And so when we add up the absolute values, it's just the numbers, right? Oh, let me add my units. Very important to add your units. All right, so we have 15 plus 45. And this number is going to give us 60 meters, right? So 15 plus 45 is going to be 60. Oh, you can't see that. Let me try and move it so you can see it. Right here is a displacement of 30 meters. And our distance here of 60 meters. All right, let me try and move it. There you go. Okay, so hopefully you can see it and have a better understanding.